Tuesday, February 13, 2024. It's about 3 o'clock in the afternoon. I have a splendid day and potentially an extraordinary night of clear seeing before me. The moon, however, is in day 3. See if we can get a look at it. Yeah, there she is. Should be low to the southwest at the time I begin imaging, around 7 o'clock this evening. I have been having an atrocious time having relocated, as I specified in the previous video, relocating the telescope. Initially, I made the mistake of lining up the tip of these anti-vibration pads right along the line of the deck. Didn't work. I've also had a problem with shifting and vibration a little bit when I am using the scope at high magnifications, in particular 150x. You'll notice that other pad is back from the deck line, and this one's in advance of the deck line. This pad over here has been pushed. Used to be maybe the back right against there. I pushed it out. I've had the benefit of a beautiful day to make sure my bubble levels were properly balanced for both east-west and north-south. So having corrected that, I also set up the azimuth adjustments here to begin with, right to the very center of the shaft. I hope you can see it in there. So the next step, what I did is I kept manipulating the declination and the right ascension, as well as allowing myself to loosen up these clutches so that I got a good balance between the bubble level in the zenith position as well as on the right ascension axis. It's a little bit off now, and there's a reason why. Because I also set up the bubble level when the scope was counterweight down, and I made a compromise between them. All purely mechanical adjustments. No electronic adjustments as of yet. So, adding a little bit of padding underneath the tripods, having done a decent job of compromising all the bubble levels in terms of the various positions, whether deck or looking to the zenith or looking to the pole, getting all that balanced out. Now, what I am doing, sorry about that. Now what I'm waiting for is the sun to drop behind the garage so that I can begin an initial settings using that lunar orb up above on such a splendid day here on the 13th, fortunately, not a Friday the 13th, but the 13th of February. It is Tuesday night, 6:45 on the 13th of February. Noon, doing all kinds of mechanical alignments to the mount, which were videoed earlier about 3 o'clock. I spent the early evening doing digital alignments for setting up the model. I got pretty decent models both to the east and the west. And however, when I came out to actually do some, to check and synchronize the mount, Rigel was up near the top. So it's still a bit questionable about whether we are going to be able to center up galaxies and other studies using the 150x version of the optical train, which is created by removing 0.5 barlow. So now we've got a 150x field of view, which I explored previously. I think it was 2 evenings ago. We have a 3-day moon. I'm going to wiggle around a little bit. I did put some padding on the floor. Oh, that looks better. All right, so maybe I've solved that problem. So let's move forward. I'm going to synchronize the mount, look for galaxies to appear at roughly this period, location on the screen, and the galaxies will all be magnitude 13.0 and brighter, beginning with the NGC 1600 series and making leaps and bounds based on that qualification. A quick check to the north. I've just moved the scope virtually directly north on the declination axis to Capella Alpha Auriga. And that is its location on the screen. So we basically shifted the scope by about 50 degrees. Rigel started here, Capella is there. That's about, probably about 3 to 4 arc minutes difference. That is acceptable. So here we go. Let's begin with our first sub-13th magnitude galaxy, which I believe is going to be NGC 1600. I have boosted the screen brightness slightly. I'll do it again just so you can see what it's at. It's at 30. So let's push it up to 35 and let it devolve out. We have oriented the scope towards NGC 1600 galaxy in Eridanus, magnitude 10.9, largest 3.1 by 2.2 arc minutes, elliptical class 2 spiral, which means it's well in the negative direction from the z=0 lenticular classes. The galaxy is 209 million light years distant, 5 degrees shy of the celestial equator. And I can see the galaxy right there quite obviously. Now, before I move on, the 1600 series galaxies have been imaged 3 times now. They were imaged at 75x about a week or so ago. They were imaged 2 nights ago at 150x, and I was not, nor should you have been very pleased with the results. What we're shooting for here is to get brighter galaxies that can show some real sense of what kind of galaxies they are. Some sense of core, extensions, and rings, and spiral arms, and elongates, even in face-on galaxies. That's our goal for 150x. Unfortunately, it also dilutes the brightness of the galaxies, which means they're fainter. So now we're going to have a chance on a very nice night of seeing, except for that 3-day moon, to see whether it's really worth the time. For if you've seen the video I posted last night, Messier 1, the Crab Nebula, looked far better at 75x, had much more presence than at 150, but as I pointed out in that video, everything at twice the magnification is 4 times fainter, or 1.5 magnitudes fainter in terms of average surface brightness. So here's our start. Now remember, there's also a 1601 in this field, and I can see it right there. And I'll give you the data on 1601, and it will continue to allow this this image to formulate. NGC 1601 is a galaxy also in Eridanus. It's magnitude 13.8. but small at 0.6 by 0.3 arc minute. It's a z=0 lenticular spiral class O, 222 million light years distant, also at -5 degrees. In terms of right ascension, we're at about hour 4:30 minutes. And there are our view. And I do believe there's another galaxy in the screen as well. I will take a look. Yes, there's NGC 1603, which is slightly larger lenticular, 228 million light years distant. And if I press go to, let's see where it jumps to. So it looks like everything shifted down to in the 7 o'clock direction from where it was initially. We can see, I don't want to shift too much here, but I do believe NGC 1600 is there. I do believe the 1601 should be there, and NGC 1603 should take up a position right about there, and I do believe we're seeing all of that. Now, on the basis of last night's explorations, it does appear that we should be able to turn up galaxies to magnitude 15.0, which is actually superior to a 12-inch scope, maybe 15 to 18-inch scope. We'll talk more about that later. Now, I know I promised not to be spending much time on anything fainter than magnitude 13.0, but this is interesting because we want to see if we can turn up a 15th magnitude galaxy. which should be the upper limit for what is possible. So I have progressed to NGC 1607. So unlike the previous 2 nights ago, I am skipping over galaxies that may not be of any particular interest to us, in hopes of characterizing and also getting some decent views on what is probably the last good night before the moon begins to dominate the night sky. NGC 1607 is also a galaxy in Eridanus, magnitude 15, but it could be 14 if 15 is actually the blue-violet magnitude. And typically on a galaxy, the visible light will be about a magnitude brighter, magnitude 14. This galaxy is kind of oblate, 1 by 0.4 arc-minute spiral, 1 step removed in the positive direction from lenticular, 190 million light years distant, and minus 4.5 degrees in declination. And I'm going to assume we're going to be able to turn this galaxy up, but I won't know until tomorrow. Here we have our first sub-13th magnitude galaxy except for the original 1600. This is NGC 1614. It's a galaxy in Eridanus, magnitude 12.9, pretty much face on, 1.3 by 1.2 arc-minutes. What makes this galaxy interesting is it's a spiral with a bar and some peculiarities. First off, we'd like to be able to image that bar, which basically, instead of having a round core to this galaxy, should have a distended linear type core to the galaxy. It's also a galaxy with peculiarities, and it would be really great if we could actually reveal the peculiar aspects of this galaxy in this 150x image. The galaxy is 212 million light years distant. Now, another thing that makes this galaxy interesting is it's at minus 8.5 degrees declination. And if you have followed the previous video, you'll know that I'm limiting this series at 150x explorative to minus 10 degrees, because after that we begin to really seriously lose some luminosity. I do believe the galaxy is right there. Now what I'm going to do is a little experiment now. Now I put some rubber material down underneath the anti-vibration pads of the mount, and I'm hoping that now when I shift my weight around it doesn't translate. And you know what? I don't see much in the way of bopping around the screen, so kudos for that. Let's hope that holds up as well. Now we're off to NGC 1618, another galaxy in Eridanus, sub-13, magnitude 12.7, largish, 2.4 by 0.8 arc-minutes, so a nice 4:1 aspect ratio galaxy, spiral with a bar, and 2 steps removed from lenticular, so a Z plus 2. 218 million light years distant, a little further north at minus 3 and change degrees in declination. I cannot tell you if it has appeared on the screen. One thing I'm noticing is there's a large triangle of, I would probably say 10th magnitude stars framing the screen, which will be quite interesting to be able to get a sense of where the galaxy is within that triangulation. Should be pretty much right towards the center. Our next sub-13th magnitude galaxy is NGC 1620, galaxy in Eridanus, magnitude 12.3, nicely aspect ratio to 2.9 by 1 arc-minute. Spiral with a lowercase c. A lowercase c means 3 times removed from lenticular z equals 0 on the Hubble tuning fork, and the lowercase c means it has a round core. So you should be looking for a brightish core with extensions going off in one direction or another. Given its 3:1 aspect ratio, it should be pretty apparent, although it won't be purely edge-on. This galaxy is 157 million light years distant, and it's pretty much butt right up against the celestial equator, so in good sky position as well. A little further south from NGC 1620 is 1622, galaxy in Eridanus, magnitude 12.5, nice large galaxy for that magnitude, 3.7 by 0.7 arc-minutes, so pretty much a 5:1 aspect ratio. Interestingly, this galaxy has a bar, but it also is a lower AB, which means that's about 1.5 times removed from the lenticular class Z. 216 million light years distant, we're at -3 and change degrees. And one of the things I've noticed about any kind of plus Z plus 1, 2, 3, 4, 5 on the tuning fork is you start to get some very strange BV deltas. And the BV deltas basically tell you what kind of light stars are dominating the galaxy's light. The closer they are to zero, the younger and more massive the stars and more luminous. So there was a recent round of star creation that pretty much characterizes the galaxies as a whole. I have not seen many galaxies that have a BV of 0, in fact none. Galaxies with a BV of about 0.7 magnitudes brighter, the visual is about 0.7 of a magnitude brighter than the blue-violet, typically have solar type stars preponderating, and those galaxies are pretty rare. Most of them have a delta of about 1, and a delta of 1 magnitude typically means you have K-class stars, which are orange dwarfs as opposed to yellow Sol-type stars that we see whenever we look up in the daylight sky and we look at our glorious solar orb. Of course, much of what I'm narrating as we look at these images on the TFT screen, real-time images, are things I have been researching and annotating in the last several releases of real-time astrovids. Now I'm beginning to assimilate it and can explain it a little better. Hopefully I can weave it in an interesting way throughout the evening and in the future. What we're seeing here is NGC 1625, another galaxy in Eridanus. It wasn't too far from the last one, which I think was 1622. Magnitude 12.3, 4:1 aspect ratio, 2.1 by 0.5 arc minutes, spiral with a bar, 2 times removed from lenticular Z, 212 million light years distant, -3.25 degrees in declination. NGC 1627 is another galaxy in the river of Eridanus. Magnitude 13, without a 0.0 or anything, so it could be anywhere. One thing I want to point out when it comes to galactic magnitude, sometimes they're the blue-violet magnitude of the galaxy, and sometimes they are the visual, which is the green-yellow. If it says magnitude 13 and it's based on blue-violet, typically the galaxy is brighter than you expect by about a magnitude, something to be aware of. And that happens about 1/3 of the time. We're getting the blue-violet magnitude rather than the visual magnitude. NGC 1627 is a 1.6 by 1.6 arc minute spiral with a lowercase c, 3 times removed from lenticular class, which means those deltas that exist between the various brightnesses can get a little weird when you start getting out to the right side of the Hubble de Vauquelaire's tuning fork of galactic morphological characterizations. This galaxy is almost -5 in declination. No idea whether it's on the screen. I'm thinking it's time to go ahead and see where one of the bright stars are on the screen to ensure that we're still getting pretty good alignments. Very nice. Here's where Rigel turned up. Wow. So we should have really captured those galaxies if they were visible. Got to move on though. I don't want the scope to be doing an equatorial flip to the other side of the sky. I want to pretty much continue to see things from west looking east. NGC 1632 is another galaxy in Eridanus, and we can have more confidence it's on the screen because we saw where Rigel turned up, and Eridanus really isn't that far from Orion. This is a magnitude 13, once again, 1 by 0.6 arc minute, 222 million light years distant. We're at -9.5 degrees in declination. That's about as far south as I want to go in this 150x series. So let's hope we get a decent view of it, and the night sky certainly should support it. Now here's an interesting study. This is NGC 1635, another galaxy in Eridanus, right up there at the celestial equator. Its magnitude 12.4, 1.4 by 1.3 arc minutes. Complicated galaxy. Spiral with a bar, but also lenticular, and halfway to an A, so it's about half removed from a Z equals 0 galaxy. Interesting thing is the galaxy has a ring. Now the problem is we may not see the ring because at 150x we do dilute out the light by, as I explained in the previous video, by 4 times or 1.5 magnitudes. And typically I say, when we were operating at 2 millimeter exit pupil, that a 12 magnitude galaxy would have maybe something like a 13th magnitude core, and any ring would be 16.5, and since at 75x we could image stars down to magnitude 17, we would get glimpses of any kind of angularity around a galaxy. So, look for it, but I don't have great hope for it. NGC 1635 is 146 million light years distant and right up against the celestial equator. And I do see the galaxy, and I believe it's right around there. Let's look for that ring. Our next study is a very critical galaxy, and I'll tell you why. It's NGC 1637, another galaxy in Eridanus. It's only about 3 degrees below the celestial equator, so well positioned in the sky. This galaxy is magnitude 10.8, largest 3.9 by 3.3, spiral with a bar, 3 times removed from a lenticular, 33 million light years distant. I would really like to see some extension on this galaxy and a hints of texture. After all, that's why we are operating at 150x. To draw out details that otherwise would be missed at a lower magnification. Obviously the galaxy is right there on the screen, but are we seeing anything that makes it worthwhile to dilute out the light? Possibly if we were seeing NGC 891 or Messier 33, which is kind of an elliptical. But anyway, possibly we would be getting good views, sub-10th magnitude galaxies, but I really would like to bring out detail in any galaxy 13th magnitude or less that we wouldn't ordinarily see if we were operating at half the magnification. Not too far from NGC 1637 was 38, galaxy in Eridanus, magnitude 12, 2.3 by 1.6 arc minute, spiral with a bar, lenticular, so it's about a half step removed. 147 million light years distant. We're at minus almost 2 degrees in declination. Galaxies have been turning up consistently right there. I am very pleased, although I will continue to slightly tweak the mechanics and the model over time at 150x. I'm very pleased with the results we're getting tonight in terms of tracking down these faint studies on such a small screen area. All right, our next study, NGC 1640, meets all our requirements for magnitude except it's too far south. It's at minus 20.5 degrees, but it's such a fine night. Let's get a sense of how good it can be when we're that far south on a superb night of seeing. NGC 1640 is a galaxy in Eridanus, magnitude 11.7, 2.7 by 2.3 arc minutes, spiral with a bar, lowercase ab, so 1.5 times removed from lenticular class Z, 72 million light years distant, and as already mentioned, we're at minus 20 and almost a half degree in declination. The galaxy is right there. Very nice. This is a superb night of transparency. Okay. From minus 20, we're now back up to the celestial equator, although we're in Taurus. NGC 1642, galaxy Taurus, magnitude 12.6, 1.8 by 1.6 arc minute, spiral with a lowercase c, round core 3 times removed from Z. 207 million light years distant. We're at about a half degree in northern declination. The galaxy looks pretty good on the Handycam screen. Okay, we're out of the 1600 to 1649 series into NGC 1653, a galaxy in Eridanus, magnitude 12, 1.5 by 1.5 elliptical class 0, which means like 8 times removed or 9 times removed from the lenticular class to the left on the Hubble tuning fork diagram. Elliptical galaxies are very mature, going through a lot of star formation. You would expect them to have a fairly broad, large delta between the blue-violet and visual magnitudes because most of the stars are very old in the reddish region, red dwarf, orange dwarf realms that provide most of its light. We're 193 million light years distant looking, and we're at minus 2.5 degrees in declination. The galaxy is quite present on the screen, but is it worth 150x dilution? Gotta check that out on the morrow. NGC 1659 is a 12.5 magnitude galaxy in Eridanus, 1.5 by 1.1 arc minute. We're at minus almost 5 degrees in declination. Galaxy is a spiral of the lowercase bc, so 2.5 times removed from lenticular class Z. 205 million light years distant. We're at minus 5 degrees in declination and about 15 arc minutes from right ascension hour 5. So very nice to look up at the Handycam display and see all the galaxies pretty much falling in where we'd like to see them. Here we see NGC 1666, galaxy in Eridanus, magnitude 12.6, 1.4 by 1.1 arc minute, spiral with a bar, lenticular lowercase a, so it's half removed from a lenticular, 122 million light years distant. We're at minus 6.5 degrees in declination, and we are not struggling with views tonight. And even if I shift around, notice, wow, shifting around hasn't caused any motion on the part of the studies, which is helping to really condense the light. Fabulous. NGC 1667 is a galaxy in Eridanus. It's also NGC 1689. Magnitude 12.1, 1.8 by 1.4 arc minute, spiral with a bar at a lowercase c, thrice removed from a lenticular to the right on the tuning fork. 204 million light years distant. We're at minus 6 and change degrees in declination. The galaxy is right there, dude. That is fabulous. We were struggling 2 nights ago to even turn up galaxies. And with the adjustments to both the mechanical, azimuth declination, alignments of the mount, plus putting rubber down underneath the anti-vibration pads on the deck, increasing the brightness of the screen a little bit, getting consistent locations of galaxies on the screen, it almost seems to be making 150x worthwhile. Another thing I'm liking about this is I'm able to skip around now. I used to try to cover every galaxy in range, regardless of magnitude and basic attributes. This is more explorative in that way. You get a little bit of a hop, a skip, and a jump going, oh, look, I must have shifted. I may have spoken too soon about vibration in the floor. Here we have NGC 1670, a galaxy in Orion, magnitude 12.7, 2.1 by 1 arc minute, pure lenticular spiral class O, 205 million light years distant. We're at minus almost 3 degrees in declination, and I can't quite figure out why everything has trails on it all of a sudden. We weren't seeing that before. NGC 1671 is a galaxy in Orion, magnitude 12.9, 1.1 by 0.9 arc minute, lenticular spiral, pure lenticular class O, 283 million light years distant. We're at a quarter of a degree northern declination, so right above the belt of Orion, maybe shot off to the west a little bit. I can't see the sky, I can't tell you for sure. Okay, quite a bit of skippage here. We're now up to NGC 1684, another galaxy in Orion, magnitude 13. Kind of large for a 13th, 2.9 by 1.9 arc minute. It's elliptical without any other designation. This galaxy is 198 million light years distant, which puts it pretty much at about 200,000 light years in diameter. Elliptical galaxies don't tend to be that large, at least proximate, within 500 million light years of our own galaxy, because they tend to have condensed out due to gravity wellage and the masses they've accumulated over time, and the fact that it turned most of it into stars. We're at -3 degrees in declination, and we're about 8 minutes from right ascension hour 5. Should be an interesting galaxy. NGC 1691 is a galaxy in Orion, magnitude 12, 1.7 by 1.6 arc minutes, spiral with a bar, and a lenticular class A, so a half removed from Z. The galaxy has a ring. Ordinarily, we'd probably see a magnitude 12 galaxy with a ring. Using 75X, we would be able to see the frontier in the distance. This galaxy is 206 million light years distant. We're at +3 and change. I'm hoping before we get to NGC 1700 that we can get a nice faint galaxy virtually overhead to get a sense of how deep we can go on this very night. Okay, I now have 2 bars left on the camera, and I'm going for a 13th magnitude galaxy, but it's at -20 degrees. Let's see what it looks like. NGC 1692 is a galaxy in Eridanus, magnitude 13, 1.3 by 1.2 arc minute, pure lenticular spiral, 473 million light years distant. Another rather large galaxy for fairly mature, but this is a lenticular. We're at -20.5 degrees. Right ascension 4 hours 55 minutes and 23 seconds. I've got 2 bars left on the camera. I'm going to be wrapping up because the next night out, when I get a chance, is going to be with the 1700 series if it hasn't advanced too far sidereally with the sun. All right, one of the more disappointing views we had the other night was of the Crab Nebula, Messier 1. And in my video, I said it's basically its average surface brightness is about 12.5 at 2 millimeter exit pupil. I believe that's what it was, and that at 150x the average surface brightness would be something like 13.5, 13.8. Anyway, have a look at this view of it. This is Messier 1. As you know, it's a supernova remnant. The star went nova, probably nova, not supernova, 1054 AD. It was noted by Chinese and Japanese astronomers at that time. That's how we know when the star went supernova. It's 6,300 light years distant, and it's already expanded out to about 8 by 4 arc minutes in apparent size. The remnant as a whole is magnitude 8.4. It's well positioned in the sky, 22 degrees, and it was, of course, the first entry in Charles Messier's Messier catalog of nebulae and clusters, which I'm not sure he called it that. He was just looking for things. He really wanted to make his name in comet hunting and discovery. But as it turned out, he's more famed. I think he did discover 5 or 6 different comets, but he is more famed for actually having compiled this list, along with Pierre Messiaen's, of about 110 different studies that might, if you stretch your imagination, be thought of as comets. Some are clusters, etc., to avoid when actually looking for the discovery of a comet. Now, I can't tell you how good the image is on the screen. It looks a little pixelated to me when I look up there, but I'm looking off axis. So hopefully this will be a better view of the Crab Nebula, as I say, Carpe Noctem.
Valentine's Day.